Okay, this is the second problem that will be on the week 7 quiz. So what it's saying is you're going to run a combustion reaction using 2.6 grams of, that should be C2H4, small 2, small 4, C2H4, and 15.7 grams of O2. All right, so what an equation is telling you here is however many moles of C2H4 you want to combust, you need 3 times that many moles of O2. So what we're going to try to figure out is, do we have more than 3 times as many moles of O2 or less? If we have more than 3 times as many moles of O2, then we're going to run out of C2H4 first. If we have less than 3 times as many moles of O2 as C2H4, then we're going to run out of O2 first. So that's what this problem is. So the way you do this, you run the reaction twice. Once where you're using all of the C2H4, and once we're using all of the O2. And then you see which one runs out before the other. Okay, so let's go ahead and just do it, and you'll see this. Okay, so first you got to do is the molar mass conversion. So C2H4. So you were given, bring this back down, you're given 2.6 grams of C2H4. And here you have the molar mass right there. Okay, and we'll multiply that. Okay, and that gives us this number right here, and I'm going to round that to 0.023. Or 93 rather, I'm sorry. Okay, now we'll do the same thing for the O2, and we're given, come back up here, 15.7 grams of O2. Let's actually do this over here. And for O2, there's our conversion. Moles goes on top. Okay, and we get 0.49. I'm going to round that to 0.5. Right there. Okay, so now this is our moles of O2 that we actually have to work with. And this is our moles of C2H4 that we actually have to work with. So the way you set this up is you come up to the 4 boxes of reactants, and in this box we put all of the C2H4 that we were given to work with, and that's 0.093. So I'm going to just write that number. You don't need to write moles, just it's all in moles. Everything now is in moles, okay? And then what we're going to say is we need 3 times as many moles of O2 as C2H4. So if we're going to be able to react all of this, we're going to need 3 times this number of moles of O2. So we're going to take that number of 0.093, multiply it by 3, and we get 0.279, right there. Okay. Now we're going to come down and we're going to combust all of the O2 that we were given. We were given 0.5 moles of O2. So we come down to the O2 row and we go below O2. So this is 0.5 moles of O2. So then the amounts that you actually have were given is this one for C2H4 and this one for O2. So just kind of keep that in mind. Now, if we want to combust all of this, we go in the other direction. We need 1/3 as much C2H4 as O2. In other words, O2 has to be 3 times this number. So we take this and divide it by 3. And we get 0.167. moles. Okay? So here's the way to check your work if you're a little confused. This number is 3 times this number. This number is 3 times this number. So just go ahead and multiply this by 3 and see if you get that or something very, very close to that. And this number is 3 times this number. So take this and multiply it by 3 and see if you get something close to that. That's the way to check to be sure you've got your numbers right. Okay, so now what we need to do is we need to ask, do we have at least this much of each of these reactants? The phrase at least means that much or more. So if I say a class at Hoover High has to have at least 20 students, that means it must have 20 students or more. It can have 20, 21, 22, 25, 30, 35, but it can't have 19. It's got to have at least 20, 20 or more. So do we have at least this many moles of C2H4? And the answer is yes, we have exactly that many. That's how many we were given. So this is a yes. Next, do we have at least 0.279 moles of O2? Well, you got to be sure you know how to read decimal numbers. We have more than that. We were given 0.5 moles. 0.50 is greater than 0.279. So we do have at least 0.279 moles of O2. So we're going to write a yes there. Now we come down here. Do we have at least 0.5 moles of O2? Sure, we have exactly 0.5. That's how much we were given. So this is a yes. So again, these two boxes are automatic yeses. That's exactly how much C2H4. That's exactly how much O2. Now we have to ask, do we have at least this many moles of C2H4? And the answer is no. We only have 0.093. That number is less than 0.167. So this one's going to be a no. You're always going to end up with 3 yeses and a no, always. All right? Okay, so that means the limiting reactant is the column goes up and down, that has the no in it. So if I do this around C2H4, this is the limiting reactant. And you don't have to write this as a complete sentence on the quiz, but you can just write C2H4. That's the limiting reactant. So one that's going to run out first, okay? How much of the non-limiting reactant is in excess? So this is the excess reactant. And we said we were given this much to work with. Well, first of all, we got to take a step back. Which of these reactions is going to run? And the answer is, it's this one up here. It's the one with the 2 yeses in it. So you're going now side to side. The row with the 2 yeses, that's the reaction that's going to run. So what it's saying is, can you combust all of your C2H4 that you were given? You were given this much? And the answer is yes. You have more than enough oxygen to do that. So you'll run out of this eventually. You'll finish this up, and you still won't run out of O2. This reaction down here, can you combust all of the O2? That's how much you were given, 0.5. You would need 0.167 moles of C2H4 to do that, but you don't have that much. So you're going to run out of C2H4. You were only given 0.093. So you're going to run out of C2H4 before you combust all of your oxygen. So no, this reaction won't run to completion. You're going to run out of C2H4. Okay, so now, getting back to the question, how much of the non-limiting, that is the excess. I used a different term, so let's be sure you're clear on that. That's the excess reactant is in excess, or how much is in excess. So this is how much you were actually given. And in the reaction on the top that actually ran, this is how much you had to use. So you're simply going to come down and do a subtraction. It's 0.5 minus the amount that you actually used, 0.279. And that is going to give us 0.054 moles of O2 in excess. Again, just give me the number. You don't have to write that all, okay? So how many moles of CO2 and H2O are produced? And this was a point of confusion. It's not that the C2H4 matches with the CO2 and the O2 matches with the O2. No. You just have to find, actually, you almost scratch these numbers, these compounds out. And you only focus on the numbers. The 1, the 3, the 2, and the 2. So it means you have twice as many moles of CO2 coming out of this reaction as you had moles of C2H4 going in. You just look at the coefficients. So if this is 0.093, then this up here is going to be 2 times 0.093. And if you multiply that, you get 0.186 moles of CO2. All right? So that's how many moles of CO2. These boxes don't matter because this reaction down here, you just draw a big line through it, does not run. So we're only interested in the one that runs, the one on the top. Now what about H2O? You can do exactly the same thing, 2 to 1, or since these two numbers are the same, then these two numbers have to be the same. So if this is 0.186, this is also 0.186. So that's how many moles you have. So you can write that down here. Okay, and there's your answer. That's how many moles of each you have. Now, finally, it's going to ask you, and I am going to ask you this on the quiz, okay? This is molar mass conversions. How many grams? Because we live in a world of grams. We want to know how many grams are we going to get out of this? How much can we weigh, okay? So, grams of CO2. So here's moles of CO2 that we got out. And here's the molar mass for CO2 right here. 1 mole of CO2 equals 44.01 grams. So you have to do the appropriate molar mass conversion. And I got that from this conversion right here. And we put grams on top, so moles of CO2 cancels and cancels. And now you just run the number. And we get I'm just going to call it 8.2 grams of CO2 is what we got out of this reaction, by using the reaction up above that actually worked, the one that actually ran. Now we do the same thing for H2O. We have the same number of moles, but you're not going to get the same number of grams. Why? Because it has a different molar mass. You get a different number of grams for every mole of H2O. So let's go down. We're going to use this one we've used many times in class. So we're going to come down here. And now we just multiply 0.186 by 18.02. And that gives us 3.4, I'll round it to, of, let's say O2, I meant H2O. Sorry. Okay, again, we're dealing with products, what comes out on the right side. Okay, so that's that for that. Okay, and that takes care of how you do a limiting reactant problem. Okay, so what I would do is practice these two problems over and over and over again for the next 2 nights until you literally have the numbers memorized, and you have more importantly, you have every step memorized as to how you get those numbers. All right, so that'll take care of this.